Alright, so there is one thing which I did not cover, which was again a big thing from Cloudflare's birthday week, I think a couple of weeks back, which was this zero latency SQLite storage in every durable object. Let's talk about this. Because this is a very interesting thing. Durable objects in general are very, very interesting as a concept. And I want to deep dive into this article. It's a mix of technical article, like the infrastructure level, how it works, plus the feature itself. So I want to discuss this with you, understand myself, what's going on over here. I have read this article briefly once. There are some questions I have and some things which you would learn from this article. Let's dive down. So you're going to start off with, so traditional cloud storage is inherently slow because it is normally accessed over a network and must be carefully synchronized across many clients that could be accessing the same data. But what if we could instead put your application code deep into the storage layer such that your code runs directly over the machine where the data is stored and the database itself executes as a local library embedded inside your application. Durable objects are a novel object approach to cloud computing. Not just the same machine, your storage lives in the same thread as your application, requiring not even a context switch to access. So let me tell you about what's going on here first of all. What's happening here is two things. The first thing is a durable object. The second thing is a SQLite. For those of you who don't know what SQLite is, I'll just quickly show you what this means. So for example, one of these coding labs on Codedam, if you take a look, you will see that there is a database.sqlite file which is available here, which exactly is like a database representation. So you see like all these tables and rows, the data where it is coming from. It's coming from this file itself. This is the whole file. This is the whole database, right? So this is what SQLite basically means. The single file which can be accessed using, there are a lot of implementations, like if you're using Node.js, then there is, I think SQLite 3 is one of the packages, but there are like bunch ships with its own default implementation. But the underlying database remains a single file, which you can then, just play around. You can put it on your file system, have like synchronous read and writes like Cloudflare is going to do in this one. So let's take a look. So durable objects, let's talk about this. Durable objects are a novel approach to cloud computing which accomplishes just that. Your application code runs exactly where the data is stored, not just on the same machine. Your storage lives in the same thread as well. With proper use of caching, storage latency is essentially zero, while nevertheless being durable and consistent. So let me tell you what this basically means. Durable objects was one of the very interesting things which Cloudflare released. What it basically allows you to do is create serverless stateful things. Essentially, what has been there as an option so far is that, let's say if I jump to another page, is that let's say if I have an EC2 machine, I can keep some state in memory, right? So for example, let's say if this is an instance that's handling some API calls and it has a rate limiter inside its memory, like it counts like how many times an API point has been hit. So this machine is a stateful machine. What this means is that there is some state which is contained in this machine which affects the next request that is coming up, right? There are then certain solutions like AWS Lambda, for example, which are stateless. So anything for a given input, its output should be consistent, right? You can have some level of state, but that's not usually recommended. Whenever you're deploying an application on AWS Lambda, it has to be stateless. What Cloudflare has done, or even before that, what if you want to create a stateful environment here? Then what? Well, in every such case where a serverless environment is there and you want some state, the state has to be outside of the environment, right? So either on Redis or on your Postgres database or whatever you're using. So the state resides in some sort of database, which becomes the stateful component, and your compute layer becomes the stateless component. What Cloudflare did is that with durable objects, it said that we don't want to have that. What they said is that within Cloudflare durable object itself, Cloudflare durable object, it fundamentally, what this technology is that it's a compute layer, like for example, like AWS Lambda, but it also gives you the ability to attach a storage thing, which is a stateful thing directly in a synchronous fashion with itself, right? So what this means is that what this unlocks basically is, let's say if you are trying to create a Google Docs like editor where 2, 3, 4 people are able to edit together. So what you can do, you can pretty much implement the same thing over here also, with the state being, detached from the compute. But over here it becomes simpler because of all the race conditions you are able to avoid, because the storage access, the read and write is synchronous, right? So you can do something like that where you attach all the 3 people to a same storage of the durable object, read and write directly from there, and your synchronous, that thing where you are accessing the read and writes together is not a race condition or something like that. So anyway, so far until today, you can see durable objects only offered key value oriented storage, but now they support a full SQL query interface with tables and indexes through the power of SQLite. So if you don't know, SQLite is indeed like one of the most popular approaches. I think probably the most used SQL database implementation in the world with billions of installations, and it's basically everywhere, right? From your mobile phone devices to anywhere which needs a SQL interface for querying. Just because it is extremely stable as a software, it's an extremely stable implementation. It carries the, some of the benefits of a typical database like Postgres. So in terms of like, the reliability of the data which is written, all of that is there. Plus you have a similar interface for querying data, just like, you have for normal things. And the most important thing is that this whole thing can reside inside a single file, right? So your database, whenever you want to just move to another machine, just copy that, paste it, it will just start working. It's known to be blazingly fast and rock solid, but it's been less common on the server. This is because traditional cloud architecture favors large distributed databases that live separately from application servers, while SQLite is designed to be run as an embedded library. In this post, we'll show you how Durable Objects turns this architecture on its head and unlock the full power of SQLite in the cloud. Very interesting. So yeah, like I mentioned to you, this is how a traditional server approach looks like. That all of these things would be, separate AWS Lambda instances would be booted up, and they would just individually connect to Postgres or Redis via a pooler or just direct connections. So this is how traditional cloud in architecture looks like, and this is what it's trying to do. This is what Cloudflare is trying to do with Durable Objects. So their app servers are separate compute instances, but everything gets a single SQLite database, SQLite database. So let's quickly walk through what are Durable Objects again. Are a part of Cloudflare Worker serverless platform. A Durable Object is essentially a small server that can be addressed by a unique name and can keep the state both in memory and on disk. Workers running anywhere on the network can send messages to a Durable Object by its name, and all the messages addressed to the same name from anywhere in the world will find their way to the same Durable Object instance. So this is the interesting part, right? So when I mentioned that you can have a collaborative text editor, somebody who's sitting in US, let's say, is accessing your editor, and somebody sitting in India is accessing that editor. So when those workers from US to India, for example, if I have a big earth here, if you have a worker over here in US and a worker here in India, both of them can access the same Durable Object, right? Now it could be anywhere. That's not your headache as a developer to realize where that Durable Object is. This Durable Object could be anywhere in the world, DO, right? But both of you guys would be accessing the same object. So this is how it preserves that way of, you just reading, both of you reading and writing to the same storage. Durable Objects are intended to be small and numerous. A single application can create a billions of Durable Objects distributed across our global network. So how this would work? Again, this architecture, you would ask me, like, how would this even scale? Well, you see that what you have to do is essentially create an infrastructure where a Durable Object spawns up for every single document, right? So let's say if you are Google Docs as a company, you would not have it's very, very rare that a single document has more than 100 or 1000 of participants at a given time, right? Even if that is the case, most of them would be viewers only. If I just have to take a bet, the average number of people who are on a given Google Doc at any time is probably around 2, like on an average multiplayer thing, 2 or 3. So for that, this constraint is very valid, right? Because Durable Object for a single document would be just, connected to 2 or 3 people, and Cloudflare can very intelligently route that location of that object to the closest wherever it is in the world, right? So if all the writers and readers are from US, it'll just put that Durable Object directly in the US, or in India if that is the case, and so on, right? So this can just go ahead anywhere in the world, and the readers and writers will follow. So this location which Cloudflare is going to change, this is automatically determined by Cloudflare, and you don't have to worry about where this is in the world. Cloudflare will do that for you. That's a great part. So they gave the same example, real-time collaborative editor. Many users may be editing the same document at the same time. Each user's change must be broadcasted to other users in real time, and conflicts must be resolved. An application built on Durable Objects would typically create one object for each document, and the Durable Object would receive edits from users, resolve conflicts, broadcast changes, all of that. These are especially good at real-time collaboration, but are by no means limited to this use case. They are general purpose servers that can implement any logic you desire to serve requests. Even more generally, Durable Objects are basic building block for distributed systems. When using these, it's important to remember that they are intended to be scale out, not up. Again, very, very important thing. Like I mentioned, SQLite in general is not like a very production heavy database. So you can't like send thousands or millions of people on SQLite database, but you can have very, very small SQLite database for individual things, right? So you scale out, not up. Scale out means that you create like many instances of Durable Objects. Scale up means that you just make this one single instance a lot more beefier. A single object is inherently limited in throughput since it runs on a single thread of a single machine. To handle more traffic, you can create more objects. This is the easiest when different objects can handle different logical units of state, like different documents, different users, different shards of a database, and so on, where each unit of state has low enough traffic to be handled by a single object. Exactly what we talked about, the Google Docs example. But sometimes a lot of traffic needs to modify the same state. Consider a vote counter with a million users all trying to cast votes at once. To handle such cases with durable objects, you would need to create a set of objects that each can handle subset of traffic and then replicate state to each other. Perhaps they use CRDTs in a gossip network, or perhaps they use an implement and fan out approach to a single primary object. Whatever approach you take, durable objects make it fast and easy to create more stateful nodes as needed. So I would say like this becomes a little complex, and if this, for example, just my 2 cents over here, if a voting counter with a million users all trying to cast vote at once, if this is your use case, if this is like really your use case, you would probably, I would say that your architecture would not consist of durable objects then you would probably fall back to a traditional server where you get a nice database like this, and then you scale out AWS Lambda instances, or even like Cloudflare workers for that matter, and you just connect with the actual database directly, where you implement the scaling up of the database and implement all the good stuff here. I mean personally I wouldn't do something like this, CRDTs in a gossip networks, or implement a fan out approach, because the approach, then you are trying to fit durable objects into a use case which it is not meant for, right? The storage thing is not meant for that. But anyway, moving on. Why is SQLite in durable objects so fast? Well, when a durable object uses SQLite is invoked as a library. This means that the database code runs not just on the same machine as the durable objects, not in the same process, but in the very same thread. Latency is effectively zero because there is no communication barrier between the application and SQLite. Reads and writes are synchronous. The SQL query API in durable objects does not require you to await the results. They are returned synchronously. This may come as a surprise to some. Querying a database is input-output, right? This is an interesting thing. What happens in a durable object is that what they have done is, traditionally, if you know any database provider you have used, you would always await it, right? Even if you're running that database on your local system, you have to communicate over the network. In this case, with SQLite, what Cloudflare is saying inside durable objects is that you do not have to await the results. That means read and writes both are synchronous. And let's understand how is that even possible. So querying a database is input-output, right? IO should be always asynchronous. Isn't this a violation of the natural order of JavaScript? It's okay. The database content is probably cached in memory already, and SQLite is being called as a library in the same thread as the application. So the query often actually won't spend any time at all waiting for IO. So the reads, what they're saying is that because it's in the same thread, same server, same process, all of that, the reads are almost instant, right? So it's not traversing any sort of network, except for if the reads are not cached inside memory, except the only network it's traversing is the local SSD, and SSDs are ridiculously fast, right? Some of these SSDs actually match the cache implementation of older things, older CPUs and all. So you can imagine older RAMs, not CPUs. You might as well consider the local disk just as another layer in the memory cache hierarchy, L5 cache. Meanwhile, synchronous queries provide some big benefits. First, the logistics of asynchronous event loops have a cost. So the common case where the data is already in memory, a synchronous query will actually complete faster than an async one. More importantly though, synchronous queries help you avoid subtle bugs. Anytime your application awaits a promise, it's possible that some other code executes while you wait. The state of the world may have changed by the time your await completes, which is true. Like, by the way, like one of the things which you have to take care of when you are using async await is that if anything else is running in the background, is that expected or is that okay for it to keep on running? Your code always executes in the order you wrote it, uninterrupted. So database experts might have another deeper objection to synchronous queries. Yes, caching may mean we can perform reads and writes very fast. However, in the case of write, just writing to cache isn't good enough. Before we return success to our client, we must confirm that the write is actually durable, which is true, right? Because databases in general are built in such a way that even if your machine crashes, for example, if a transaction is going on and if the machine crashes, the consistency of the database must not be lost, right? So it should be durable. If your application says that I have written something, then that better mean that the next time I read it, even if the machine has crashed, so some other object is reading it, it should be there. So what they're saying is that before we return success to our client, we must confirm that the write is actually durable. That is, it has actually made it out to the disk or network storage such that it cannot be lost if the power suddenly goes out. Normally, a database would confirm to all writes before returning to the application. So if the query is successful, it is confirmed. But confirming writes can be slow, right? So this is important because this cannot be synchronous, right? You cannot just block thing. And if you do block the thing, then of course it will be very, very slow because you have to traverse whatever Cloudflare is doing under the hood in order to store that SQLite file. It would be slow because it requires waiting for the underlying storage medium to respond. Normally, this is okay because the write is performed asynchronously. So the program can go on and work on other things while it waits for the write to finish. It kind of looks like this. So exactly like this, whenever a write happens, you would put probably an await or something like this, where when that await is waiting for that IO operation, another request can come in and start to consume resources, right? So this is usually not a problem, but I just told you that in durable objects, writes are synchronous. While a synchronous call is running, no other code in the program can run, which is true. This is convenient, as mentioned above, because it means you do not need to worry about the state of the world may have changed. However, if write queries have to wait a while and the whole program must pause, wait for them, then the throughput will suffer, which is again true. So you now have a problem. Luckily, in durable objects, writes do not have to wait due to a little trick we call as output gates. So again, something which Cloudflare implemented as a custom infrastructure. In durable objects, when application issues a write, it continues executing without waiting for the confirmation. However, when the durable object then responds to the client, the response is blocked by the output gate. The system holds the response until all storage writes relevant to the response have been confirmed and then sends the response on its way. In the rare case that the write fails, the response will be replaced with an error and the durable object itself will restart. So even though the application constructed a success response, nobody can ever see that this happened, and thus nobody can be misled into believing that the data was stored. So what they're saying is a request comes to a durable object writes to a storage service, it responds, it sends the response that okay, I have written something like this, something whatever it is, but the Cloudflare would on an infrastructure level would block it until this confirmation from the storage relay service comes. Once this confirmation comes that everything is synced, then the response would be sent to the client. If while this confirmation is waiting, if something happens like the storage service goes down or the durable object crashes or something, then this whole response, Cloudflare is saying, we will just send an error response instead of that, and the whole thing would restart. This durable object service in itself would restart. Okay, I have a problem with this approach. So the problem with this approach is that I'm just trying to find some examples, or maybe even counter is fine, counter for just keeping it simple, right? So what's going to happen? See, let's take a look at this example. This is an interesting example. So what's going to happen? Let's say we are implementing this counter with SQLite as a storage mechanism. Now, when the request comes on this durable object, let's say, because these APIs would be synchronous, right? The get and set would be done on with this syntax, the syntax for SQL, right? SQL.exec. So you'll have a select query. Let's imagine like this is not asynchronous, this is synchronous, because right now they are using the get, the key value pairs. Let's say you get the value, which is great, but when you are setting this value, let's say you set this value and you figure out whatever that number is, let's say that 100 or whatever it is, right? And once that, let's say if this value hits certain number like 1 million, for example, you have a logic here that performs a fetch request to your server for whatever logic. So the fetch request awaits, right? So it awaits and it says that, you know, great, you have hit 1 million users or something like that. And that is the point where this durable object crashes, right? A very, very rare condition that the object crashes, the storage layer or whatever, this case where they mentioned that if it crashes, the output gate will block it and it will not respond until it gets the confirmation. So let's say this call succeeds, the write call, this decrement call, this call succeeds. In the next line, you perform a fetch request. So this call, the set call to the SQLite in the user land succeeds, right? So this call, whatever, let's assume that this is like an update call or whatever, this succeeds. The output gate call fails, but I have already sent my fetch request to my server. So what has happened here is that the system now is inconsistent because there is no way to guarantee in the user land that the call would 100% succeed. I think this implementation is not good. I would say like for very, very rare edge cases. I might be wrong. I might be understanding this thing wrong, but I would love to like, I'll tag a couple of people from Cloudflare, see if they respond. How do you prevent that? If I have a fetch request, again, to an external server, that depends on the state of the SQLite instance, which is attached to this durable object, and that call succeeds, I send the request, then the worker fails, then the thing fails or whatever, the write does not happen. What happens in that case? So that's my first question, right? That's my number one thing. Other than that, obviously, if you're not doing any sort of external thing, or if you are just 100% relying on durable objects, this is fine because, you know, the end user will anyway see an error if the system crashes. So they'll know like their request did not complete or whatever. But what I'm trying to say here is that there is possibility of side effects here. If you have certain side effects that depends on the storage to be written, there is no real way to know that the storage has actually, you know, the storage is written on the disk. So I don't know like how, if this is a problem at all, if they're trying to solve this, how would that work? N+1 selects, no problem. Zero latency queries aren't just faster, they allow you to structure your code differently. A classic example is N+1 selects or N+1 queries. Okay, let's illustrate this problem with an example. So you get all the docs, 100 docs, and then for every doc you get the author name. If you're an experienced SQL user, you are probably cringing at this code, and for good reason. This code does 101 queries. If the application is talking to the database across a network with 5 millisecond latency, which is really good, this will take 505 milliseconds to run, which is slow enough for humans to notice. Here we have used SQL features to turn our 101 queries into one query. Great, except what does this mean? We used an inner join, which is not to be confused with a left, right, or cross join. What's the difference? Honestly, I have no idea. I had to look up joins just to write this example, and I'm already confused. Well, good news. You don't need to figure it out, because when using SQLite as a library, the first example above works just fine. It will perform about the same as the second fancy example. More generally, when using SQLite as a library, you don't have to learn how to do fancy things in SQL syntax. Your logic can be in regular old application code, in your programming language of your choice, orchestrating the most basic SQL queries that are easy to learn. It's fine. The creators of SQLite have made this point themselves. The SQLite website itself says that n+1 queries are not a problem with SQLite. SQLite database runs in the same process. Queries do not involve message round trips, only a function call. The latency of a SQL query is far less in SQLite, hence using a large number of queries with SQLite is not a problem. See, that's fine. I agree with this whole thing, but still let's not just direct people to just not know the difference between these two things, because most people, if they are working on a production level application, they are just not working with SQLite alone. They are working with Postgres, they are working with MySQL, where your exact example turns into like a real use case. And if you're not working on your side project or something like that and working in a real company, then just taking this approach and calling it a day over there would hurt your infrastructure in general. So I'm not saying that you should be learning about SQL in depth or all of that, but still know like what's the difference between this and this. Even if you're writing it in a SQLite, I don't fully agree that you should not know about what's going on over here. It's always better to know and then choose whatever you want. You can choose either of these examples, because like he said, the performance is same, but you still should know like what's going on under the hood. Then there is point in time recovery, all of that good stuff that Cloudflare provides right out of the box. Then there's a little bit of example. This is where I'm trying to understand what's going to happen. Let's say this initialize flight is an async function. It creates this, insert into seats, whatever. Here at this point, it performs a fetch request to an external service, my AWS Lambda backend or whatever, saying that the seat was created. And at that point itself, this whole thing crashes. How would this prevent? How, like, is this a known thing? First of all, I'm trying to understand that. Is this like expected to happen? If yes, then shouldn't like there be a big disclaimer that do not use any external services with Cloudflare durable objects, which could like result in inconsistent systems if you have like a second storage layer somewhere else. So I'm trying to understand that. Or, if there is something like this where, I have a function which gets executed after the durable object has returned, but before, the durable object execution closes. So it has returned and it has written something on the storage layer. Then maybe if I have a callback or something like that, maybe in that callback I can perform that request, right? But I don't know if that exists right now. That would be one way to solve it. So again, the pricing is nice. Cent per million rows, row reads. Rows written is $1 per million rows, and SQL storage is 5 GB per month included, plus 20 cents per GB month. So yeah, this is interesting because reads especially depends a lot on how your query, how the database engine, SQLite in this case, decides to go through the rows and all. So yeah, pricing really depends on your use case. If you're doing something extremely heavy, this might not make a lot of sense for you. If you're doing something relatively light, then sure. So a little bit about under the hood storage relay service. When durable objects first launched in 2020, it offered a simple key value based interface. Under the hood, these keys were stored in a well-off-shelf database with regional instances of this database deployed to locations in our data centers around the world. Durable objects in each region would store their data to this regional database. For SQLite-backed durable objects, we have completely replaced the persistence layer with a new system built from scratch called as Storage Relay Service, or SRS. SRS has already been powering D1, which is another database from Cloudflare, for over a year and can be used more directly with applications through durable objects. SRS based on a simple idea. Local disk is fast and randomly accessible, but expensive and prone to disk failures. Object storage like R2 is cheap and durable, but much slower than local disk and not designed for database-like access pattern. Can we get the best of both worlds by using a local disk as a cache on top of object storage? So a SQLite database on disk tends to go under many small changes in rapid succession. Any row of the database might be updated by any particular query, but the database is designed to avoid rewriting paths that it didn't change. Reading queries may randomly access any parts of database. Assuming the right indexes exist to support the query, they should not require reading the parts of database that aren't relevant to the results and should complete in microseconds. Object storage, on the other hand, is designed for an entirely different usage model. You upload an entire object blob of bytes at each time. Each blob has a different name. For maximum maximum efficiency, blobs should be fairly large, from hundreds of kilobytes to gigabytes in size. Latency is relatively high, measured in tens or hundreds of milliseconds. So how do we back up our SQLite database to object storage? An obvious naive strategy would be to simply make a copy of the database files from time to time and upload it as a new object. But uploading the database on every change and making that application wait for that upload to complete, because remember that there is still an output gate, right, which needs to wait for the upload to complete, would obviously be way too slow. We could choose to upload the database only occasionally, say every 10 minutes, but this means in case of disk failure, we could lose up to 10 minutes of changes. Data loss is bad, and even then, for the most databases, it's likely that most of the data doesn't change every 10 minutes, so we'd be uploading the same data over and over again. Trick 1. Upload logs of changes. Conveniently, SQLite itself has already a concept of changelog, the write-ahead log or val. SRS always configures SQLite to use val mode. In this mode, any changes made to the database are first written to the separate log file. From time to time, this database is checkpointed, merging the changes back into the main database file. The val format is well documented and easy to understand. It's just a sequence of frames where each frame is an instruction to write some bytes to a particular offset in the database file. Okay, so they operate SQLite in val mode. SRS then monitors changes to val file to discover changes being made to the database and uploads those objects to storage. Unfortunately, SRS cannot simply upload every single change as a separate object, as this would result in too many objects, each of which would be inefficiently small. Instead, SRS batches changes over a period of 10 seconds or up to 16 MB, whichever happens first, and then uploads the whole batch as a single object. When reconstructing a database from object storage, we must download the series of change batches and replay them in order. Of course, if the database has undergone many changes over a long period of time, this can get expensive. In order to limit how far it needs to go, SRS also occasionally uploads a snapshot of the entire content of the database. SRS will decide to upload a snapshot at any time the total size of logs, since the last snapshot exceeds the size of database itself. Okay, so they have some level of algorithm over there. This heuristic implies that the total amount of data the SRS must download to reconstruct a database is limited to no more than twice the size of database. Since we can delete data from object storage that is older than the latest snapshot, this also means that our total stored data is capped at 2 times the size of database size. Credit where credit is due, this idea of uploading val to batches and snapshot in object storage was inspired by Lightstream, which is another service which is fully replicated database with no pain and little cost, which works on SQLite, right? Something like this, but their implementation is different. The next trick is to relay through other servers in our global network. Batches are only uploaded to object storage every 10 seconds, but obviously we cannot make the application wait for 10 whole seconds to just confirm a write. Of course, right? You have that layer of that output gate. So what happens if the application writes some data, returns a success message to the user, and the machine fails 9 seconds later, losing the data? This is what exactly was my question also. To solve this problem, we take advantage of our global network. Every time SQLite commits a transaction, SRS will immediately forward the changelog to 5 follower machines across our network. Once at least 3 of these followers respond that they have received the change, SRS informs the application that the write is confirmed. As discussed earlier, the write confirmation opens the durable object's output gate, unblocking the network communications to the rest of the world. To solve this problem, we take advantage of global network. Every time SQLite commits a transaction, SRS will immediately forward the changelog to 5 follower machines across our network. Once at least 3 of these followers respond that they have received the change, SRS informs the application that the write is confirmed. As discussed earlier, the write confirmation opens the durable object's output gate, unblocking the network communications to the rest of the world. Okay, so in fact, the thing is that once the durable object has even responded, even then, by even that time, it's not guaranteed that your change is written to the network, to the log or whatever, to the actual disk, to the object, what am I saying? To the object storage, which Cloudflare uses under the hood. Because it only informs 3 more machines or 5 follower machines in their networks, and 3 of them respond that we have got the change log. Then it just opens the gate. When a follower receives the change, it temporarily stores it in a buffer on a local disk and then awaits further instructions. Later on, once SRS has successfully uploaded the change to the object storage as part of the batch, it informs each follower that the change has been persisted. At that point, the follower can simply delete the change from its buffer. However, if the follower never receives the persisted notification, then after some timeout, the follower itself will upload the change to the object storage. Thus, if the machine is running database suddenly fails, as long as at least one follower is still running, it will ensure that all confirmed writes are safely persisted. Very interesting, but this reliability is not 100%, right? So there is like a 99.9999999%, because there could be a case where the primary machine fails, the writes don't happen, all the 3 confirmation machines fail somehow, whatever, something has happened, and the writes which are guaranteed to the user never got written, right? There is a case, I was just telling you about this case, right, where the fetch request automatically, that system becomes inconsistent. But the same thing is also possible within Cloudflare's own infrastructure, where the durable object returns the same write response to the client that, it's great, everything is working. The primary backup, the SRS on the primary instance fails. SRS on all the 3 other instances also fail, which is highly, highly unlikely, but it can still happen. There is a probability which is greater than 0. Interesting. Each of database 5 followers is located in different physical data centers. Cloudflare networks consist of hundreds of data centers around the world, which means it's always easy for us to find 4 other data centers in a nearby durable object. In order for a confirmed write to be lost, then at least 4 machines in at least 3 different physical buildings would have to be failed simultaneously. 3 of the 5 followers plus the durable object's host machine. Of course, anything can happen, but this is exceedingly unlikely. So this system, I won't say like it's unreliable or something, but it's not 100% reliable, right? It doesn't come with 1 0 0 and then a percentage sign. It would come with 99 point a lot of nines, maybe like 8 nines, 9 nines, 10 nines. But if you are that one unlucky customer, then something can happen with you someday with this architecture. Followers also come in handy when a durable object's host machine is unresponsive. We may not know for sure if the machine has died completely or if it's still running, responding to some clients but not others. Yeah, so all these things can happen. We cannot start up a new instance of the durable object until we know for sure the previous instance has died, or at least that it has no longer confirmed writes. To deal with the situation, if we can't reach durable object's host, we can instead try to contact its followers. If we can contact at least 3 of the 5 followers, then tell them to stop confirming writes for unreachable durable object instance. Then we know that the instance is unable to confirm any more writes going forward. We can then safely start up a new instance to replace the unreachable one. Awesome. Very interesting blog post, very long video, I think one of the longest ones which I've created in some time. But let me know what do you think about this whole architecture. Very interesting thing from Cloudflare. Do let me know in the comments if you like this video, if you have any learnings, any understandings. That's all for this one. I'm going to see you in the next video very soon.